Compound events are more than one thing. Okay? More than one event. And so figuring out all of the different possibilities when there's more than one thing happening is part of the challenge for compound events, for multiple things. The beginning of this, page 733, Amy is packing outfits. She has a jacket, 3 shirts, and 2 pairs of jeans. Can she make 6 different outfits with this combination of clothing? Well, one thing you do is just try to list out all the different outfits. Jacket is always there because she has no choice of jacket. She can wear shirt 1 with jeans 1, or shirt 1 with jeans 2. Or shirt 2 with jeans 1, or shirt 2 with jeans 2. Okay? Or she could wear shirt 3 with jeans 1.
She's seriously wearing
Or she could wear the jacket and shirt 3 and jeans 2. Right? So these are all of the different outfits that she can make. How many different outfits are there? There are 6 of them. This is called an organized list, right? Just kind of trying to go through the list and alternating the things. There's other ways to figure out this list of possible outfits. And one of them that's kind of makes it a little bit easier, although it's maybe more work, is by doing a tree diagram. Okay, a tree diagram puts each level of choices. So first we have a jacket, which you have to have a jacket, so there's no other choices there. Then the next choice would be the jeans. Okay, so she wears the jacket and jeans 1, or the jacket and jeans 2. Then once you pick the jeans and the jacket, you now have shirt choices. So from each jeans, you have the multiple shirt choices. Shirt 1, shirt 2, shirt 3. Or jeans 1 with shirt 1, shirt 2, shirt 3. Okay? This is a tree diagram. Okay? So you make the different choices, different levels here, and off of each first choice, then you can put all the choices for the next thing. Okay? At the bottom here, it gives you every path down the tree are your different results. Those different results are called the sample space. The sample space is all the possible outputs you can have. Right? So it's jacket, jeans 1, shirt 1, jeans 1, shirt 2, jeans 1, shirt 3, jeans 2, shirt 1, jeans 2, shirt 2, jeans 2, shirt 3. Just like this. Okay, it's just a different way to organize them. We'll look at another example here in the next problem. Okay, so the list of all of the possible results is called the sample space, listing them all out, the full combinations, all the different ones you can get. Okay, this one, putting these guys in order, I'm going to skip because talking about ordering things is better in a future topic. Okay, but this one we'll talk about. A car can be purchased blue, silver, red, or purple. It also comes as a convertible or a hardtop. So the tree diagram, pick the color choices first, blue, silver, red, or purple. And for each of those colors, then you can go convertible or hardtop, convertible or hardtop. And so each branch here, each branch is one of your answers. Mr. Riley's branch here, my car.
It's open.
It's open.
My car is a blue, it's open. Orange folder. Okay, is a blue convertible. I drive a blue convertible. Okay, my son drives a red convertible. Yeah, he has a BMW Z4. My wife drives a silver hardtop. Okay, each branch of the tree, right, is a different car result. How many different car possibilities are there here? 8. Okay? So you can use either method. You can just kind of list them out, which is a little bit challenging. It's easy to miss one, or do it as a tree diagram. Now the next slide I should fix because I exposed the answer. So I'm gonna freeze. I'm gonna go over here and put a big old box over this.
It's not frozen.
What?
Yeah, it's
I'm
not
kidding.
Why I ought to.
It's actually not frozen. Your duration.
All right, that's better. Okay, so the table here shows sandwich choices for a picnic. You get a choice of meat and a choice of bread. What is the sample space? The sample space are how many different sandwiches are there? Okay? Just so when you draw your tree diagram, first you have a choice of meat. So what are these two branches going to be? Ham and turkey. Ham and turkey. Oh, I would pick turkey every time. Okay, you can abbreviate here, right? Ham and turkey. All right. Then, if you pick ham, what are these three things coming off of ham? Rye, sourdough, and white, the three bread choices. Okay?
Dude, sourdough's so good.
Sourdough's fantastic. I had sourdough toast this morning at Dunkin' for lunch. Avocado and bacon toast.
Sourdough is the best type of bread.
You know, I forgot I have my latte over here. I should probably.
Sourdough. It's just like bread but sour, but it's so gas. No, it's good.
Big one.
It's the best bread ever.
6, you're right. Rye, sourdough, or white with a turkey. So what's written under here for sample space? HR, HS, HW, TR, TS, TW, right? These are the 6 possible sandwiches. That's the sample space. The 6 possible sandwiches. Okay. Next, we're going to talk about very common thing that you get in games, which is rolling 2 dice. Okay? Lots of games have you roll 2 dice. Monopoly, Parcheesi. Okay? Lots of games use rolling 2 dice. If I roll 2 dice, how many possible outcomes are there?
5. 20.
12 is the most common answer. 12 is the most common answer when I roll 2 dice. Yes, you are wrong. You're close, but you are wrong. All right, here's 2 dice, rolling. Rolling 2 dice. A 6, I got a 6, I got a 4, I got a 6, I got a 12, I get a 4, I get a 4, 2. All right. So what are the 12 possible outputs you can get then, Cole?
Oh, no, there's 6.
6. What?
Wait, no.
What can you get when you roll 2 dice?
12.
What are the 12 results? 1 through 12, you say, right?
1, 2, 3, 4, 5, 6, 7, 12.
Tell me how you're going to roll a 1 with 2 dice. Oh, wait a minute. You can't roll a 1 with 2 dice.
You throw the other one.
Throw the other one outside the room.
You can't roll a 1. You can roll 2. Okay? So how many possible results are there? 11. 11 possible results. What is the probability of rolling a 12 with 2 dice? 1 out of 11, you say. Why not?
Yeah, why?
Just like, no, it's not.
Is it easy to roll a 12 with 2 dice? Does it happen a lot?
Yes.
It doesn't happen a lot. Does it happen the same amount as other numbers? Why not? Is there an equal chance of getting each of these numbers on 2 dice? Is there an equal chance? Are each of these have the same number of chances when you roll 2 dice? No, you don't. Okay, here's why. The 2 dice aren't really these 2 white dice. It's really a red die and a green die. Think of them that way. Okay? So first I roll the red die. How many possible results are there? 6. 6 possible results for the red die. Then I roll the green die. How many possible results are there? 6. So how many combinations of results of red and green dice can I have? How many different results are there? 6 for the first one. So the red die, who said 36? Somebody smart. Right? 1, 2, 3, 4, 5, or 6 on the red die. And then the green die, if I get a 1 on the red, there are 6 chances, 6 different outputs on the what? On the green one. 6 different outputs on the red, on this one. If it's a 3 and 6 different. And over here, a 6 and 6 different outcomes, including this one, a 6 on the red and a 6 on the green. That gives me a 12. How many other ways are there to get a 12? How many other ways are there to get a 12 besides a 6 on the red and a 6 on the green? None. That's the only way to get a 12. There's only one chance of rolling a 12 out of how many possibilities? How many possibilities? 36. There are 36 different results when you roll 2 dice. 36 different results. A lot of them have the same sum. They add up to the same number. But there's 36 different combinations of red die and green die. 36 different combinations. Which of these is the most common result? What comes up the most when you roll 2 dice? What number comes up the most? 4? How many results are there that add up to 4? No, this one, and this one. That's it. 3 out of 36 add up to a 4, right? A 3 and a 1, a 2 and a 2, or a 1 and a 3.
Is it 8?
Yeah. How many ways are there to get a 7?
64.
There's only 36 possible results. There are 6 different combinations that give you a 7 as the sum. 6 different results. A 6 and a 1, a 5 and a 2, a 4 and a 3, a 3 and a 4, a 2 and a 5, or a 1 and a 6. 6 different results. 6 different results give you a 7. So if you're playing Monopoly and you are 7 spaces away from something you want, that's a good place to be. Because what's the probability of rolling a 7 when you roll 2 dice? 6 out of 36, which simplifies to 1/6. Right? The probability of rolling a 7 The probability of rolling a 7 is 1 out of 6. Every 6 rolls, you should get a 7, theoretically. How often should you get a 12?
Why?
One,
Out of how many?
36.
1 out of 36. Right? 6 times harder to get a 12 than a 7. What other number has 1 out of 36 as its probability? What other number is 1 out of 36? 2. 2. There's only one way to get a 2. 1 and 1. How many ways are there to get an 11? 2. 6 and 5 or 5 and 6. Right? The sum is the same, but there are different results on the dice. Right? That's why there's 36 different results. Okay? So this is really important to know if you are a game player. Right? That the probability of getting a 7 is high. Higher than any other number. The probability of getting a 1, a 2, or a 12 is very low. If you're playing with 3 dice, this becomes even much more complicated, right? There are 216 different outcomes with 3 6-sided dice, right? 6 times 6 times 6 again, right? So each one of these would have 6 different yellow dice coming off of it. And the probability then of getting 3 1s if you roll 3 dice is 1 out of 216. Another example here. Oh my gosh, look what time it is. 3 coins. 3 coins. How many possible outcomes are there if I flip 3 coins?
6.
Nope. 8. 8. The first coin can go heads or tails. From that coin, the second one can go heads or tails. So there's heads and tails off of each of the first coin. And then off of each of these, the third coin, heads or tails again. What's the probability of getting 3 tails? Tails, tails, tails. It is 1 combination out of 8. There are 8 combinations in this sample space, right? 8 possible outcomes. So the probability of getting 3 tails when you flip 3 coins is 1 out of 8. Okay? Favorable outcome divided by how many possible answers there are in the sample space. Okay, so this is the second thing that you need to be able to do. We'll do one last example here. The animal shelter has male and female Labrador retrievers, and they're yellow, brown, or black. Equal numbers of each kind, so if you randomly pick one, what is the probability that you're going to get a female yellow Labrador retriever? Well, first you have to get how many different possible dog combinations are there. So if I want to do that with a tree diagram, what's the first level of the tree diagram?
Quick question.
Male and female. Okay? Yes, Roman.
Brown, yellow, and black.
Right, off of each of these, then, there's brown, yellow, or black. So how many different dogs are there in this? Dog choices are there? 6. There's female yellow, female brown, female black, male yellow, male brown, male black. Okay? And you can organize that by doing a tree diagram. The probability then of picking female yellow is 1 of the answers out of the 6 possibilities. So the answer is 1/6. Okay?